Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Automated Power Factor Correction and Surge Protection Mr. K. Vishnu 1 Assistant Professor, Department of Electrical and Electronics Engineering, Venice Institute of Technology and Science, Telangana. Anish Kumar 2, L. Lohith Akshay 3, G.Yashwanth Reddy 4, B. Chandar 5 UG Student, Department of Electrical and Electronics Engineering, Venice Institute of Technology and Science, Telangana. Abstract: Automatic power factor correction is the capacity reactive power, kVAR, to maintain the magnetic field. This of absorbing the reactive power produced by a load. In case of fixed reactive power is necessary for the equipment to operate, but loads, this can be done manually by switching of capacitors, however imposes an undesirable burden on the supply, causing the in case of rapidly varying and scattered loads it becomes difficult to current to be out of phase with the voltage. Current lags the maintain a high power factor by manually switching on/off the capacitors in proportion to variation of load within an installation voltage. Low power factor can also result when inactive motors. This drawback is overcome by using an APFC panel. In recent years, operate at less than full load such as a surface grinder performing the power quality of the AC system has become great concern due to a light cut, a circular saw that is only spinning, an air compressor, the rapidly increased numbers of electronic equipment, power that is unloaded, etc. Losses caused by poor power factor are due electronics and high voltage power system. Most of the commercial to the reactive current flowing in the system and can be an industrial installation in the country has large electrical loads eliminated using PFC, which are severally inductive in nature, causing lagging power factor, which gives heavy penalties to consumer by electricity board. In this paper we are using a method of the reactive power situation is taken care by a PFC. In this paper measuring of power compensation by capacitor switching with automatic control factor from load is done by Arduino and trigger required capacitors using Arduino and protection of equipment from the surges. In order to compensate reactive power and bring power factor near to unity. Two existing methods. There are several existing procedures for power factor keywords, A ampere, ADP alternative transient program correction in modern days. APFC automatic power factor correction, CT current transformer, kVA kilovolt ampere, kVAR kilovolt ampere reactive, kW kilowatt, kilowatt hour, LCD liquid crystal display, PCB printed circuit board, PF power factor, PFC power factor correction, PT potential transformer, R resistive, RL equals resistive inductive, RMS root mean square, THD total harmonic distortion, V volt, ZCS zero current sensor, ZVS zero voltage sensor. Asynchronous condenser. The synchronous motor has long been used as a compensator with fixed ratings, known as a synchronous condenser. Compensation is achieved by setting the field excitation to arrive at a particular rating. A disadvantage of this device is that it is electromechanical and requires some maintenance. Since the degree of compensation is predetermined, introduction as with a fixed capacitor bank, synchronous condensers have little power factor is defined as the ratio between the kW, actual appeal over capacitors. Accordingly, their application in the load power, and the kVA, apparent load power, drawn by in mining industry has been limited, except in cases where salvaged electrical load. It is simply a measure of how efficiently the load ones were available, at an attractive price. Current is being converted into useful work output. Modern industries using mechanized methods suffers from low power factor due to the use of different electric equipment which requires more reactive power. Significant savings in utility power costs can be realized by keeping up an average monthly power factor close to unity. Utilizing shunt capacitor banks for power factor correction, PFC, is an exceptionally established methodology. The recent trend is to automate the switching procedure of capacitors to get greatest advantage in real-time basis. Embedded systems based on microcontrollers can be used to monitor and control the switching of correction devices because of its dependability and execution. All inductive loads require active power, kW, to perform the actual work, and B static capacitor bank. The application of shunt capacitor banks results in a decrease in the magnitude of the source current, improves the power factor and consequently improves voltage regulation throughout the system. However, Shunt capacitor banks do not affect current or power factor beyond their point of application. Capacitor banks can be fixed, switched, or a combination of both. The switching process can be manual or automatic. Capacitor banks are rugged and simple to configure and install. See others methods. There are also some other complicated methods invented for PF correction which are not much popular for economical. IJERT 10 is 060194 www.ijert.org 528. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Purpose and some methods are under research. Our developed system is based on power factor correction using capacitors as it is convenient for economic design. PF will be determined by the microcontroller and capacitors will be introduced in the system. Automatic switching of capacitor combination ensures the desired amount of PF correction and eliminates overcorrection. 3. Proposed system. The proposed system takes 230 V 50 Hz mains supply as a power source and steps down the voltage level to 12 V through a PT. The power supply unit then converts this 12 V AC into two different DC power consisting of +9 V and +5 V. The sample voltage signal is obtained from this 12 V AC signal and processed through the voltage sensor circuit for microcontroller input. A current signal sample is also obtained from the main supply by a current transformer and processed by a current sensor circuit for another microcontroller input. The microcontroller performs power factor calculations and switches capacitors from the bank. The results are displayed on a 20x4 LCD display. The functional block diagram of the complete project is shown in the following figure. Fig 2 Prototype of proposed system. Fig 1 Block diagram of the APFC. Fig 3 Surge protector. 4. Design methodology. The automatic power factor correction device is developed built on embedded system having 89S52 at its core. The voltage and current signal from the system is sampled and taken as input where the difference between the arrivals of waveforms indicates the phase angle difference. The difference is measured by the internal timer and calibrated as phase angle to calculate the corresponding power factor. The system power factor is compared with the desired level and the difference is measured for switching of required number of capacitors from the bank. The values of power factor and phase lag are shown on a display for convenience. IJERT 10 is 060194 www.ijert.org 529. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 V Results Analysis 11 Chowdhury, SM, Design and Implementation of a Low-Cost Power by Using the System Automated Power Factor Control Factor Improvement Device, IEEE Region 10 Conference 10CON, and Surge Protector. The system automatically corrects the 2008, pages 1-4. Power factor when it is below the unity power factor. The Surge 12 using LCD module with AVRs, available http://extremeelectronics.co.in/, accessed on February 4, 2015. Protector is used for protection of the equipment form voltage 13 Ali, Murad. Design and implementation of microcontroller-based surges in the system. 6. Conclusion. Automatic power factor correction techniques can be controlling of power factor using capacitor banks with load monitoring. Global Journal of Researches in Engineering Electrical and Electronics Engineering version 1.0 13.2, 2013 N page. Web. Online. Applied in industries, commercial lines, and power distribution system to increase stability and efficiency of the system. Care should be taken so that the capacitors are not subject to rapid and off-on conditions as well as overcorrection, otherwise the lifespan of capacitor bank decreases significantly. The APFC device helps to pull in high current drawn from the system and reduce charges on utility bills. A reduced power consumption results in lower greenhouse gas emissions and fossil fuel depletion by power stations and would benefit the environment. Acknowledgement. We are thankful to our principal Dr. G. Kumar for giving us permission to carry out this project. We acknowledge Dr. T. Rama Subbareddy, Head of Department of Electrical and Electronic Engineering, for his guidance and moral support throughout the project. We extend our sincere thanks to Mr. K. Vishnu, Assistant Professor Electrical and Electronics Engineering, for her guidance and valuable suggestions, bondless cooperation, and encouragement throughout the project. Lastly, we also extend our thanks to all the staff of the Department of Electrical and Electronics Engineering, VITS, for their cooperation and support during our coursework. References: 1 Alexander, C.K., and Sadiku, M.N., 2007. Fundamentals of Electric Circuits. Boston, McGraw-Hill Higher Education. 2 Shwedi, M.H. and Sultan, M.R., Power Factor Correction Capacitors, Essential and Cautions, IEEE Power Engineering Society Summer Meeting, 2000, pages 1317 to 1322. 3 Stephen, J.C., 1999. Electric Machinery and Power System Fundamentals. 3 RD.ed United States of America, McGraw-Hill Companies, Inc. for Power Factor Correction, www.nhp.com.au. NHP Catalog, PFCSFC, November 2007. Web. July 14, 2016. Available at https://portal.nhp.com/power quality 5 Power Factor Correction, a guide for the plant engineer, www.eaton.com. Eaton Corporation, August 2014. Web. July 14, 2016. Available at www.eaton.com/ecm/group/public/@pub/SA02607001e.pdf6 Hudson, Glenn. Open Energy Monitor. https://openenergymonitor.org/eman/modules/eman-txv3np, ND Web. July 14, 2016. 7 Microcontroller. Wikipedia https://n.wikipedia.org/wiki/microcontroller. Wikipedia Foundation, ND Web. July 14, 2016. 8 Evans, Brian. Beginning Arduino Programming. New York, A-Press, 2011. Print. 9 Monk, Simon. Programming Arduino, Getting Started with Sketches. New York, McGraw-Hill, 2012. Print. 10 Hobbyist.co.nz. Interfacing the relay modules to the Arduino, http://www.hobbyist.co.nz/interfacing-relay modules-to-Arduino right bracket. NP, ND Web. July 14, 2016. IJERT 10 is 060194 www.ijert.org 530. This work is licensed under a Creative Commons Attribution 4.0 International License.